So today we're on lesson 3.3, and this lesson is giving you all the rules for differentiation. In 3.1, we gave you the definition of a derivative. We told you that we were looking for a point that's really, really close to the actual point that we're looking for, the slope. And then that as h approaches 0, that's really the difference between the point that we're choosing versus another point that we're using to figure out the slope, right? So in calculus, that method is super, super long, and it's really not super convenient. So we have a shortcut for you. The shortcut is using these rules of differentiation to help you find the derivative, aka the slope of the function. All right, so from this point on, you don't have to do the long way. You don't have to do the definition way, which is using the limit. You will use these rules to find the derivative or the slope of a function, of any function. With different functions, there are different rules. So we're going to start with the most basic ones. We're going to start with the power function, power polynomial functions. And also from this point on, we're no longer going to call it a slope. We're going to call it derivatives. So whenever you hear the word derivative, you're looking at the slope or the instantaneous velocity of that particular function at a particular point. Okay. So the rules of a constant function. So the derivative of a constant function. So look at it as the slope of a constant equation, like y equals 3. It is a horizontal line, right? Therefore, the slope is 0, and that we already know. So again, look at this as y equals a number, or y equals a constant. This is a horizontal line. Therefore, the slope is 0. That makes sense. This thing, this power rule, is the most important one we're going to use. So anytime you have x to a power, the rule is you drop the power down to be a coefficient now, and then you subtract 1 from the power. So for example, if I'm asking you to take the derivative of x cubed, drop the 3 down, and now minus 1 to your exponent is now 3x squared. All right, so that is going to be super helpful. Even if your exponent is a fraction, it's going to follow the same rule. So for x to the 4/5, you bring it down, or ddx, sorry, you got to take the derivative. So bring down the 4/5 x, and now you got to be quick enough to think that, all right, 4/5 minus 1, so that's a negative 1/5. So even if it's a fraction, the rules still apply. You drop down the power and you subtract 1 from the power, the previous one. If you have a constant multiplying by your function, you can take the constant out and then take the derivative of what's left over here. Again, this is not going to be super obvious for us until later on, okay? You can add your function. You add multiple terms. So for example, if you're taking the derivative of x cubed plus 2x, it will be, you take the derivative of that one, so 3x squared, you drop down the 3, subtract 1 from the power, and then the 2 is a coefficient, right? Because think about it, 2x is a linear function, so the derivative of that is just the m, it's a slope, it's a 2. So that is a derivative of the entire thing, the entire thing of x cubed and 2x. When you're combining those, your derivative, you add the derivative together. Most important thing of today are these two rules: the product rule, well, other than the power rule, the product rule, and the quotient rule. You really want to memorize these, right? So again, some books have it differently. When you have a product, when you're multiplying two things together. So again, right now, it's not going to make a lot of sense because we only have polynomial functions. But later, when we have trig functions, when we have sine, cosine, tangent, when we have natural logs or each of the x functions, any of those functions, then using this rule is going to be super helpful. So the rule is, or the formula is, you take the original function, the first function, and then you take the derivative of what's next door. Then you take the derivative of the first one and you keep the next door. So this one's a little bit, I wouldn't memorize it as uv prime plus vu prime, because then a lot of students think, oh, this only works when you're multiplying two things together. This works when you're multiplying three things together. So if you're taking the derivative of a, b, c, then it would be, the way I would do it is, I would take the derivative of the first one, keep b and c together, then take the derivative of the second one, keep the other two, and then take the derivative of the last one, keep the other ones. And that is a true product rule. So anytime you're multiplying multiple things together, you take the derivative in order, so you don't lose it, and you take it one at a time, one term at a time, and then all the other ones stay the same. And again, we're going to see that in our examples in the notes today. Okay. And then this one, again, some people memorize it as vu prime minus uv prime all over v squared. That's another way to memorize it. I had a really nice teacher who taught me this. So this is the higher function. This is the lower function. So he goes low d high minus high d low all over low squared. So low d high minus high d low all over low squared. So again, whatever way you want to use to memorize this is fine, but you must memorize this. I don't know how many times I need to emphasize this. This is super important to know your quotient rule. Oftentimes I have students who refuse to memorize this and they would just take the derivative of the top and then the derivative of the bottom. That's not the case. It totally doesn't work. So you must know that this is either vu prime minus uv prime over v squared, or low d high minus high d low all over low squared. Either way, memorize this. Okay? All right, let's see it in action. So let's find the derivative. So it says find the derivative. Some of these I will ask you to take more derivatives. So you take the first derivative and you take the second derivative. And there is a point to it, but not yet. I will tell you why we're doing it later. Right now, you're just learning how to do it. All right. So you need to be able to take multiple derivatives. Sometimes they want you to take the third, the fourth, the fifth derivative. Sometimes they want you to take derivative all the way to the zero. So really got to read the directions in your homework. All right. So that's why on these, the direction just is find the derivative. And some of these I want you to find one or two and just kind of follow along. Okay. So the first one, I want you to find the first derivative. So the derivative is denoted by a little prime. So if you find the first derivative of this is g prime of t, all right, your coefficient is still there. The 6 is still there. Now we're working with a t to the 5/3. So t to the 5/3, drop down the power. So 5/3 is now your coefficient. T, and then 5/3 need to subtract 1. So really you're subtracting 3 over 3. That gives me 2/3. Okay, clean this up. You get 10t to the 2/3. That's your first derivative. Okay, now if I want second derivative, that means you just keep going. You take the derivative of the previous one. So it is a little bit dangerous because if you get the first derivative wrong, there is really zero chance you will get the second derivative correct because it's a domino effect. Your second derivative depends on your first derivative. So always double check that your first derivative is taken correctly. All right, same thing. We'll keep the 10. The 10 was a coefficient. Drop down the 2/3, that was your power. T to the, all right, now 2/3 minus 1, that will give me negative 1/3. All right, so to clean this up, you get 20 over 3. T to the negative 1/3 makes it t to the 1/3 in the denominator. You can leave it as a cube root, right? We know 1/3 is cube root, and it's actually okay in calculus to keep it as a root in the denominator. It's more important that you leave it in the denominator than to leave it on top, and we'll see why later on. Okay. Okay, in number 2, you have a true polynomial function. So only a true polynomial function will you be able to keep taking derivative and eventually be 0. So let's take a look at what's going on here, all right? So f prime of s, your first derivative here, your 15 is a constant. It's a number. It has no variable with it whatsoever. So the derivative of a constant is 0. So the derivative of that is 0, gone. Next term, you have negative s. Negative s is essentially negative 1 times s. So you have a coefficient in front of the s, and so your derivative is negative 1. That is your coefficient. Plus, now you're going to slowly get used to this, and again, eventually we are hoping that you can just take your coefficient and multiply by the exponent and just do that in one take. So you can go ahead and do 4 times 2, that gives me 8, and keep s to the 1 power, and then minus 5 times 4, 20, s cubed. So that's the first derivative. All right, let's keep going. Second derivative. Okay, in the second derivative, this negative 1 is a constant, so it'll go away, becomes 0. The 8s will give me the coefficient of 8, minus 20 times 3, that's 60s squared. Okay, I'm going to clean up a little bit because I don't want to write that on my derivatives. All right, keep going. We still have some terms here. F triple prime of s, all right? So 8 is a constant, it's gone. So I'm left with negative 60 times 2, negative 120 s to the 1 power. Okay, now what, Ms. Chu? You really want us to put 4 dots there? No, once you're past the third derivative, you put a little 4 in parentheses. That means it's the fourth derivative, and your book denotes it this way, okay? And then this, since this is a linear function, negative 120s, your derivative is just negative 120. And then if you keep going, right, if you take one more derivative, you'll see the derivative of a constant is 0. So this one takes 5 steps to get to 0. And the trick is to see that your highest power is the fourth power here. You usually need one more step, one more derivative to get to all the way to 0. So if I have something to the 6th power, you will need 7 derivatives to get it to 0. Okay, so in this problem, when we are presented with a problem like this where there's roots and there's exponents, the best way to approach this is to rewrite it as an equation with exponents, right? So you rewrite this as f of x equals 3x squared. The first thing is okay. And write it as x to the 4/3. Remembering our root is the denominator in our fraction, right? Now that you've rewritten it this way, now it's a lot easier to take the derivative. So my first derivative will become f prime of x equals 6x. Remember, you take 3 times the 2, right? So 6x plus, there's no coefficient on this one, so just drop the 4/3 down, x to the 1/3, right? Now, you want to take a second derivative on this because I want you to practice that. So take the second derivative. So f double prime of x. The 6x has a coefficient of 6, right? Plus, now practice taking your fractions, multiplying fractions. So now you have your 4/3 and your 1/3. Multiply those together. You get 4/9 x to the negative 2/3, right? Now, because now you have created more fractions here, you really want to be in a good habit of rewriting this. The first term you could rewrite it too, so we actually should. So we want to rewrite all these into fractions so it's a lot easier to work with later on. So this will become 6x plus 4x to 1/3 all over 3, right? Oh, that one's over 3. So you want a common denominator of this, and hence making this 18x plus 4x to 1/3 all over 3. All right, so that will be your first derivative. Your second derivative will do the same thing. We'll have 6 plus 4 over 9, x to 2/3. So you want to multiply this. So you can do the crisscross applesauce too. It'll still work because they have no common denominator. So this will give you 54, x to 2/3, plus 4, all over 9, x to 2/3. All right. Again, we're not making this prettier. I totally understand that, but there is a definite pro. There's a definite good thing to this, to writing it as one fraction, because when we use it later on, this is so much easier to use than the original form. Okay, so in this problem, we have a product here. And normally with a polynomial function like this, I would recommend that you go ahead and multiply this out and get it so that it's a long standard form, and then take the derivative. But because we don't have enough tools to show you that product rule really works, we're going to show you using this, that product rule really works. All right, so remember, product rule is g prime of x. We take the derivative of the first one, which is 3x squared. Keep the same thing next door, so 2x squared plus 3. Okay, now we keep the first one, x cubed minus 7. And now take the derivative of the second one, that is 4x. Okay, we're going to distribute and multiply this out and see if we can clean this up. I get 6x to the 4th plus 9x squared. Okay. Distribute 4x backwards, so 4x to the 4th minus 28x. Right. So you will get 10x to the 4th plus 9x squared minus 28x. All right. So that is using the product rule. Now again, normally I would suggest that you go ahead and multiply this out. So if we were to just multiply g of x by distributing the x cubed first, so I'm going to distribute this first. So I get 2x to the 5th, right, plus 3x cubed. Now I distribute negative 7, so minus 14x squared minus 21. So this is a rewritten standard form of the same exact equation. Now in this form, it's a lot easier to take the derivative. So I go g prime of x equals 10x to the 4th plus 9x squared minus 28x. And see? My two answers are exactly the same. All right, so again, there is no pro and con when it comes to polynomial functions like this. But later, again, if we're introduced to cosine x and sine x and all the other fun functions, then this product rule is going to be super handy. Okay. All right. Again, in a problem like this, like number 5 here, especially when you only have a single term in the front like this, I would go ahead and distribute this out and not use a product rule. So I would suggest to rewrite my equation by remembering that 3x, 1/2, and 2, you're supposed to add them together, and you want to rewrite it as an improper fraction. So not 2.5, but 5 over 2, minus 2x, this is x to the 1 plus 1/2, that's 3 over 2, right? Plus 5x to the 1/2. Now written this way, it's a lot easier to take the derivative. So f prime of x equals, go ahead and multiply 3 times 5/2. Don't forget you just multiply the numerators, right? So that's a rule of our multiplying fractions. Subtract 1 from 5/2, so this 3/2, minus 2 times 3/2, that gives us 3, x to the 1/2, and then plus 5/2, x to the negative 1/2. Again, typically this is okay, but you really want to make sure you are comfortable to know how to write this as one fraction, right? This is 15x 3/2 all over 2 minus 3x to the 1/2 plus 5/2 x to the negative 1/2, right? So x to the 1/2. So how do you rewrite this as one fraction? You need to have some common denominators here, right? So you need x to the 1/2 here, and this one needs 2x to the 1/2, like so, right? So if you common denominator this actually gives you 5x to the 4, not 4, sorry, 5x squared, because 4/2 is 2, right? And then minus 6x, you have 1/2 plus 1/2, so 1, right? And then plus 5 all over 2x to the 1/2. You want to do that because notice now you actually have a really nice term on the top that you can do something with rather than having all these x to 3/2 and x to 1/2. So cleaning it up actually does help, okay? All right, moving on to number 6 here. So again, problems like this, I would strongly recommend you multiply it out, but because this is notes, we're trying to practice using product rule. So we're gonna try practicing product rule with this, right? Okay, prime of x equals, take the derivative of the first one. The derivative of this is 4x minus 4. The second term gives me minus 4. All right, keep the next door neighbor, 6x minus 5, okay? All right, and then my second term, plus, product rule is always plus. Plus, keeping the original first equation. And then the derivative of the second one is just 6. Okay, now you do have to clean this up, so make sure you distribute and clean up. I get 24x squared minus 20x minus 24x plus 20. And then plus 12x squared minus 24x plus 6. All right, clean this up. I get 36x squared. I'm looking, right? And then I have minus 20, minus 24, minus 24. So minus 68x, and then 20 and 6 plus 26. That would be my first derivative, okay? Okay, and number 7 here, we have a quotient. So when you have a quotient like this, you have to use quotient rule. So sometimes it helps to write the derivative at the top. U prime is 4, and write the derivative at the bottom. V prime is 3. U is always top, V is always bottom, right? And now don't forget to remind yourself of the little saying, low D high, so low D high minus high D low all over low squared, right? Do not do this. Every year I have students go, oh, can we just cancel these out? No, they don't cancel out because you did not factor it out from both of the top terms. So please, right now, take some time to simplify the top. You never need to multiply out the bottom. Always, always work on the numerator. So you get 12x plus 8, don't forget your minus 12x plus 15 all over 3x plus 2 squared. And this one beautifully turns into 23 over 3x plus 2 squared. Very unlikely will I ask you to take the second derivative of this because you don't have enough tools right now to take the second derivative. So this is usually where we end, okay? Let's practice again using the quotient rule in the next one. So you have u prime, the top derivative is 8. V prime is t minus 2, 2t minus 2, because you got to bring down the exponent. All right, so you now have your quotient rule, f prime of t, oh, not x. All right, f prime of t. All right, so low d high, low d high minus high d low all over low squared, okay? Remember, we don't need to work on the denominator, just work on the top. So 8t squared minus 16t plus 24 minus, since there's so many terms here, I would suggest to go ahead and multiply the two terms out first, then distribute them minus, right? So you have 16t squared There's plus 30t minus 16, so plus 14t and minus 30, right? So again, I did the distributive property and multiply those out. And then all over t squared minus 2t plus 3 squared. Okay, so if you distribute and add them up, you have 8t squared minus 16t squared, so negative 8t squared. Negative 16t minus 14t, so minus 30t. 24 minus negative 30, so plus 54, all over t squared minus 2t plus 3 squared. This one won't factor. Most likely these don't factor out, but again, if you want to, it doesn't hurt. You can see that they all are divisible by 2 on the top, so it doesn't hurt to put that in, or you can take out negative 2 because some people don't like negative t squared. I'm one of those people. So 4t squared plus 15t minus 27, all over t squared minus 2t plus 3 squared. Okay, you don't have to do this last step of bringing out the negative 2 unless it really helps you factor some things out, but it's not a bad habit to keep, okay? All right, next one, same idea. I would strongly recommend you rewriting a t first, rewriting this first equation to t to the 2/3 all over 3t minus 5, right? And then now it's a lot easier to see that, okay, well, my derivative on top is 2/3 t to the negative 1/3, and the derivative on the bottom is just 3. Okay, now I can use my low d high, right? So low d high minus high d low all over low squared. Again, our denominator really doesn't do much. We just kind of keep it there, but you really got to multiply out the top, right? So this one's a little bit trickier, right? So 2/3 multiplied by 3 is 2. T times a t to negative 1/3, so it's 1 minus 1/3, so t to the 2/3, minus 10 over 3, t to negative 1/3, minus 3t to the 2/3, over 3t minus 5 squared. So you can see the first term and the last term actually have the same power, so you can combine like terms. So you get negative t to the 2/3, minus 10 over 3 t to negative 1/3, all over 3t minus 5 squared. This one you can clean up more because of negative 1/3, but for the sake of, in the interest of time, we're going to stop right here and go ahead and leave this answer. But again, just remind yourself that that negative 1/3 will go downstairs. You got to clean this up a little bit more to make it one fraction, okay? All right, what about an equation like this? So an equation like this, a fraction equation like this, what you want to do then is rewrite it. You always want to rewrite to be exponents. So 1 over x can be rewritten as x to negative 1. 1 over x squared can be rewritten as x to negative 2. And then x to negative 3. Rewritten it like this. So again, rewrite your roots, rewrite your negative exponents, rewrite your fraction as negative exponents. Makes it a lot easier to take the derivative up. All right, so p prime of x now, the first term is gone. Bring down the negative 1, so negative x, bring down negative 1, and then make sure you subtract 1 from your power. So negative 1 minus 1 becomes negative 2, right? And same thing, bring down a negative 2, and then subtract 1 from the power, it gives negative 3. Bring down negative 3, x to negative 4. Now, you got to be comfortable enough to know that you can rewrite this, right? So negative x squared minus 2 over x cubed minus 3 over x to the 4th, right? Be comfortable enough to shift back and forth between writing as a negative exponent and then writing as a fraction. Now, just to kind of re-emphasize my what I said before, only a true polynomial function will get to 0, right? These are not true polynomial functions because let's take a look if I do take one more derivative. You will take negative, and again, when we take one more derivative, I go back to this line right here. I don't use the fraction one. I go back to the negative exponent one to take the derivative. It's a lot easier to use that one. So I go negative times negative 2, that's positive 2, x to negative 3. Negative 2 times negative 3 is positive 6, x to negative 4, positive 12, x to negative 5. And again, if you rewrite this, it's 2 over x cubed plus 6 over x to the 4th plus 12 over x to the 5th. So as you can see, I'm not reducing the number of terms. Whereas in number 2 here, my terms got less and less and less. I went from 4 terms to 3 terms to 2 terms to 1 term, right? But here, I didn't. Aside from the one that was a constant that went away in the first place, I still have all my x terms. So these fractional exponents and these negative exponents will not go away. The only thing that will get us down to 0 is when we have positive integers for our exponents. Okay. All right. So what about something like this? Well, again, at the current level that we are at the current stage we are at, we don't have enough tools to help us with this. So the recommendation is just write it out as 5x minus 4 times 5x minus 4 and use your product rule, right? So product rule says h prime of x equals, the derivative first one is 5 and keep 5x minus 4, right? Plus, all right, now the first term was 5x minus 4. The derivative is also 5. And now go ahead and clean this up. 25x minus 20 plus 25x minus 20, and you will get 50x minus 40, right? And if you want to factor, again, it's not a bad idea, 10 times 5x minus 4, and you will see that this is going to be helpful later on. All right, so you will see that you have 10 times 5x minus 4 if you were to factor out the 10, okay? All right, last one, same idea here that I would strongly recommend, since again, you don't have enough tools right now. So write it as 2w plus 1, 2w plus 1, 2w plus 1. You just need to keep in mind that when you're taking the derivative, you go s prime of w. I'm taking the derivative first one, so that's 2. And then these two are exactly the same, so 2w plus 1 squared, right? And then plus, all right, now I'm looking at the second term. That one has a derivative 2. And then these two has to stay the same, so 2w plus 1 squared again. And then last but not least, I'm taking a derivative of the last one. This last one also has a derivative 2. And then these two stay the same, so 2w plus 1 squared. So again, really you have 2w plus 1. There's 3 of these. So you have 3 times 2w plus 1 squared. So this is really 2w plus 1 squared. All right. You don't need to multiply it out. In fact, we like our answers as factored as possible. So if you can factor, leave it as factor form and not as a multiplied out form. Okay. All right. Again, this lesson, I think I went over it pretty fast. So if you need to rewind or rewatch any part of it, feel free to do so. Really, really make sure you understand how to do your power rule, quotient rule, product rule. Okay. That's it, guys.